Hey guys, Cooper here, Diesel Power Products. And for this portion of things, we're going to talk about some functional bling. We've got some components here that we're pretty excited to talk about, their inner workings and their additions to what your system already has and how they're going to improve things. And they all came about for you, Gale, with your rear diff cover.
Yes.
You figured out some airflow characteristics and how to kind of pull some live air and use it in a space that would normally have dead air and use it for cooling properties.
Exactly.
And then transferred that over to everything else.
Mm-hmm.
And on your diff cover, you have these cooling fins. A lot of people don't really understand those. Can you kind of explain how those work and how they transfer that
Absolutely.
heat?
From inside?
Yeah.
Yeah. Basically, the problem we were trying to solve is how the hell lots of guys have put flat back diff covers, fins on them, curved with fins, that type of thing. But really, this is a dead airspace. Mm-hmm. Once the vehicle starts moving, this is on the differential. Diffie's out here, and it's parting the air that's coming underneath the vehicle around the differential. So the fins behind are in stagnant air. Mm-hmm. This air that comes around the Diffie doesn't come back to full velocity and merge together again until 20 to 30 inches after the back of the diff. So our problem was we put a Dodge Cummins 1-ton dually on our dyno, ran it at 250 horsepower, did an infrared scan of the tin diff cover, and kind of watched the temperature. After a couple of hours, the lube temperature got close to 400 degrees. And you could smell that truck everywhere up there in the dyno area, especially when we pulled the cover. Mm-hmm. And the fluid was toast. So we got a problem here. We were running huge airflow into the truck to duplicate road conditions.
Mm-hmm.
So I started thinking, the marketing guys had showed me let's do a Banks flat back. It'll say Banks on it, it'll be product ID. I went, those flatbacks have a problem because you're putting an impact surface right where the ring gear discharges into the cover. So the first thing you want to do is realize the factory guys who design these differentials understand what the hell that curved back cover is for. We went inside and we put fins in wherever we could pack them. And these fins help to radiate oil out into the axle tubes and get to those bearings out here.
Yep.
So that's what these are for. These have parallel, what we call flow-through fins, where the fin sits on the fin inside and basically gives you the shortest heat path to out here. Now the problem becomes, how do we cool these? We came up with these two areas hang below the diff, but not so much that you can't jack it up. These still jack up beautifully. These hang down. They're set up to deflect the air up into the fins on both sides. So you get a cooling action going here that's totally absent without them. Now guys say, well, those hang down, they might hit something like a rock.
Right.
So I finally went, let's make them break away. So these, the way we cast the fins, they have thin sections that allow them to break away if they're impacted hard enough.
Yeah.
Without breaking the seal or losing any fluid. The diff remains intact, fluid tight. This is gone. If that happens, I will replace the diff cover for free. That's how rare it happens. It has happened. We have replaced them. So there you go. We've got an airflow thing going on here. We've got flow-through fin design, and we're air cooling the fins.
And you made it a functional heat sink at that point.
Exactly. We may pick up a little capacity, but not a great deal. Mm-hmm. The other thing we found was if you fill them excessively, the ring and pinion foam the living hell out of the fluid. Mm-hmm. How do we know this? We made a clear cover with the curvature and everything else, but more of a stock thing. And then we filled it. There's a lot of aftermarket guys make diff covers.
Yep.
And they want to load the oil in there as if that's going to give you better cooling. It only gives you delayed heat saturation. Yeah, delayed heat saturation. So my thing was, we really don't need a lot more oil. We need to cool the oil that's there and not aerate it. So a similar aeration thing to what we do with oil pans and et cetera. So that's the diff cover. That starts the whole ball rolling. And we make these for the popular
light duty pickups.
Yes.
And you added a couple other features while you're holding it up.
Oh,
you got a
yes.
sight glass for the oil level and a spot for a temperature sensor.
Yep. And also,
for those of you that really want to know what your vehicle's doing.
Yes. And also a nice O-ringed fill port at the top. Kind of blingy, stainless steel type of stuff.
Yeah, it's easy to see the design characteristics and how you've carried them over into this Allison trans fan, which this This thing's pretty spectacular. One, you increase volume almost 2 quarts. Is that what I saw?
Yep.
And then you figured out a way to, again, make a functional heat sink by picking up air out of an area of velocity somewhere away from where the pan is.
Exactly.
And pulling it across.
So this is under the truck, and as mounted under the truck, this is down. Inside, you see the fins. Those fins align. They are perfectly aligned on these fins. So that's our flow-through fin design. The air scoop is under the truck.
I like how you made the air scoop a separate piece too.
In the wintertime, you might decide you don't want it.
Right.
4 bolts and it's off. I mean, you're under the truck, 4 bolts, done. Also, if you hit it with anything hard enough, there's a breakaway feature right here and here, so it just pops off and it's gone. And this is still intact. You don't scrap the piece. This is less jeopardous than that.
Yeah.
It's higher up in the truck, above the frame rails, as I recall. The other thing is, just like this is die cast. Why die cast as opposed to sand cast? Well, the stock pan, it's not sand cast aluminum, it's steel. So you have no casting sand still in the casting. Most of the aftermarket does not do die cast. Why don't they do die cast? It's expensive as hell. You turn around and you don't get sand migrating out of the casting into the lube oil.
And you get a smoother,
Better
so
flow.
for everything
you
to
get
flow
quicker
back.
return to the pickup. That isn't as draggy as sand cast.
And you're not introducing, obviously, the main point you're making, any contaminants into your system from anything that was stuck in the porosity of that
Exactly.
casting process.
You never can get all the sand out. So anything that holds lubricant, I've never done sand cast. It's either metal or it's die cast. So there you have it. That's a ram air transpan. Airflow in,
Across that heat sink.
into this heat sink. It tails out through here, and it's very effective.
And then the last piece of the puzzle on this is we've got, obviously, the stock stamped oil pan for that engine, which, some of the key things that I see just looking at this, you have a nice machined flat surface here. So you don't have to worry about leakage over time or anything else of that nature, whereas the stamped steel can distort depending on how tight you went. Torque wrench wasn't calibrated right. Elbow wasn't calibrated right. You're going to end up with some
You load it up differently.
gappage there. And then just visually looking at these and having some time to look at them, if I'm looking at stuff like your drain for your oil pan in comparison to the drain on your cast pan, this drain in your die cast pan actually sits lower.
It's at the low point.
Yes, so everything can evacuate the oil pan as expected, and you can put fresh new stuff in there.
Yes. Here, this weld nut sticks up about 3/4 of an inch to this drain plug screws into. This weld nut right here retains oil in the pan. You never get a full drain. But more importantly, the pickup tube sits in the oil. So you've drained it, the pickup tube is still in the oil that remains. So the pickup tube doesn't drain. So how do we know that this is a big deal? We drained it, we pulled the pan, glug, 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 it runs out. We took the pan, poured it into a beaker, 9/10 of a quart.
Wow.
Right at 1 quart, didn't drain. So it's more than just that. What happens?
Everything that's in the pickup tube as well.
Yeah. Now there's a feature on the bottom of the pan, this dimple right here. I don't know if you can see that on camera, but that dimple lines up with the pickup aperture, this. So when that pickup is in there, the flow into the pickup is streamlined by that internal bump in the pan.
You get a better rate of flow into it for pickup.
Yeah, more uniform flow and less turbulence at the inlet, which is called cavitation. So it's oil inlet cavitation is virtually solved with what GM did right here.
And
so
you designed that.
It's in our pan as well. I've never seen it in another aftermarket pan. Here we have a die-cast pan.
With those same, again, carried over heat sink flaps that carry on through to the outside as well.
So this is all about flow back to the pickup as well. We've got the rise, so the pickup location aligns on that rise perfectly. And we've got the slick surface, the low drag die-cast surface. The fins align with fins on the outside of the pan, so you have flow-through fins. And we pick up about 2 quarts here with this one as well. But the main thing is it cools better. So we've also got a temperature probe capability there to measure sump temperature directly, and a magnetic drain plug. And the drain plug, of course, is at the low spot.
Designed at the low spot.
Exactly, the very lowest spot. So there you get an idea of the fins. And there's early and late, I think it's 17 to 19 and 20 and up. So there's 2 different fin layouts, 2 different cross member locations, etc., and a different bolt pattern on the later one. So we have 2 part numbers for this. Yeah, the other thing I wanted to mention is all of these long fins can't be sandcast. They won't pull out of the mold well. So to try to do that, they make the fins further apart, thicker, tapered on the sides. We can have our way with proper air coupling from the fluid in the pan to the cooling air.
Nice.
Stuff you just cannot do in a sandcast.
Well, that's about it. We've just covered volume increases and the cooling characteristics from the engine to the rear differential. If you have any questions on these parts or want to purchase some for your project, check out the link in the description or visit the website, dieselpowerproducts.com.